All right, it's time to talk quadratic inequalities. And before we do that, I just want to talk a little bit about the difference between an equation and an inequality, and a few graph examples, and then we'll get to our goal for the video. So first of all, this is a linear equation, y equals 2x plus 3. It's in slope-intercept form. It starts at -3. Y-intercept, it has a slope of 2, so it goes up 2 over 1. Connect the dots. Okay, this is a graph of a linear equation. This is a linear inequality. So instead of points that lie along the line being the only solutions that make this thing true, in this one all of this shaded region makes it true. Actually, points that lie along this line don't make it true because our symbol is just greater than, not greater than or equal to. So if a point is on the dashed line, it doesn't make it true. But anything above it, because it was greater than, anything up there does make it true. All right, so there's the difference between the graph of a linear inequality and a linear equation. Now, if we talk about solving a linear equation, 2x minus 3 is equal to 11, this is going to have one solution. 2x is equal to 14, means x is 7. There's only one value of all the numbers that will make this true, and that's x equals 7. Now if I replace my equal sign with a less than sign, I get 2x is less than 14. The steps to solving this are the same, with the one exception of if you ever divide by a negative or multiply by a negative, you have to point the sign the other way, a lesson you learned at some point in Algebra 1. But other than that, the only difference is when I'm done, I don't have one number, 7, that makes this a true statement. I have infinitely many numbers. In this case, anything less than 7 makes it true. So 6 makes it true, 6.881 makes it true, 6.999 makes it true. 7 does not, but anything less than 7. So starting at 7, moving downward, not including 7, those all make it true. So this is the difference between solving an equation in one variable and solving an inequality in one variable. One solution versus infinitely many solutions. As far as graphs go, here's a quadratic graph, x squared plus 2x minus 5. This is what we've been talking about. We've been talking about the vertices and the intercepts and all the characteristics of this graph. So here's just the regular equation. I've got another couple copies. I want to say what happens if we change that equal sign. Now I want to see what happens. Let me take this equal sign out and replace that with a less than. So my graph's still going to be in the same place. Okay, that's not going to change. What is going to change is where my solutions are. If I just have a less than, this is actually going to become a dashed parabola, just like it was when we did the straight line. And I need to shade on one side of the parabola, just like I shaded on one side of the straight line. And since this is solved for y and it's a less than, I can just shade underneath. Now underneath this parabola is kind of more like around the outside edges of it, but it's below the parabola and it's everything up and down the left and right sides. But this is an example of a graph of a quadratic inequality. And what if I had, instead of equal than, greater than, or equal to, then I'm going to have the solid parabola, the same place as it was when it was an equation, and I'm going to shade everything inside. All of these values make a true statement. If I sub the x and the y in, then the y is greater than x squared plus 2x minus 5 or equal to. All right, so as with the straight lines, I wanted to start with just a picture first and then get to the kind of equations and inequalities we're going to be solving. Okay, so let's start with this quadratic inequality. The key to solving one of these is to figure out the break-even points, where this thing equals 0. And we've spent a lot of time talking about intercepts. This quadratic expression will equal 0 at these locations. If I factor this thing, it's going to factor to x and x, and then the two factors of negative 21 that add up to negative 3. I'm just realizing that's not the number I wanted to put. Let's make that 28. Go back and change that 21 to a 28. The two factors of negative 28 that add up to negative 3 are negative 7 and positive 4. Now, there's a couple of ways you could attack this problem. 7 and negative 4 are my break-even points. This thing is going to change from positive to negative at the places where it equals 0. And this thing equals 0 at negative 4 and 1, 2, 3, 4, 5, 6, 7. This is where that's going to change, meaning it could either go from negative to positive or positive to negative at one of those places, therefore changing whether this is a true inequality or not. But since we're talking about a quadratic and a parabola, and it's a positive, there's no negative sign out front here, it's a positive parabola, this thing opens upward, meaning it comes down through negative 4 and it goes up through positive 7. It crossed the y-axis down here at negative 28 just because of this being our y-intercept, but that's not really the issue. My issue is where it's crossing the x-axis, and it has to have this shape. It cannot have this shape because it's a positive quadratic, not a negative quadratic. So think about the options. If I want to know where this thing is greater than 0, really it has to be on the outside edges, right? It has to be out here. This thing is greater than 0, as in the parabola is up above the x-axis, and it returns to being above the x-axis out here. So it's from 7 out and from negative 4 out. It is not going to be greater than 0. It's less than 0 here in the middle where the parabola has dipped down below the axis. So rather than doing, when you learn this, you might learn about test points, like let me plug in negative 5 and see whether that's above or below. I would encourage you just to think about the shape of the parabola. If it's opening upward and it's a greater than question, then the outside edges are going to be the answers to that question. So this thing is greater than 0. We're going to do a little interval notation from negative infinity to negative 4. Now with interval notation, we're either going to use parentheses or brackets depending on if that number is included. With infinity, we never include it. So it's going to be a round set of parentheses around negative infinity. And in this case with 4, 4 does not work because this is just greater than, not greater than or equal to. So the negative 4 is not part of the solution set. So this thing is true from negative infinity to negative 4 because that's all of this region out here where the parabola is above the axis. Then it stops being true in the middle, and then it starts being true again starting at 7 and going on to infinity. Again, the round parentheses because I don't have the or equal to under my greater than sign. So find the zeros by factoring, which we've done plenty of. Think about the shape, and then write your final answer in interval form. One final example. This one has got a 3 or a negative 3 in common. We're going to approach it the same way. We're looking for zeros. If I factor out this negative 3, I'm left with x squared plus x minus 12. Okay, now that negative 3 tells me a couple things. It's been stretched out to be 3 times steeper than it was, and it also opens downward. This is an arch shape, not a bowl shape. So I still want to find the zeros, so let me continue factoring. X and x, two factors of negative 12 that add up to positive 1 are plus 4 and minus 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. That means this thing has zeros at negative 4 and positive 3. These are the points where the parabola crosses the axis. So these are going to be the endpoints of my intervals where this thing is true. So you can sketch it if you want. Negative 4, positive 3. it's opening downward. The steepness is not really an issue, but this happens to be a pretty steep parabola. And the question is, where is this thing less than or equal to 0? Now I switched my sign to less than, but I also flipped my parabola upside down. So this thing is less than 0 out here when I am to the left of -4. So negative infinity to -4. Now, because of this or equal to, that means -4 does make it true. So I'm going to do square brackets around the -4. Infinity always gets around parentheses because infinity is not really a real number, so it's not included in the interval. It just means that I go forever to the left. Now that's also going to include everything from 3 up. So it's going to be over there, and or is a U for union. Just if you see that, that's not really the subject we're talking about, but if you see this U, that means union. That means we're either over here or we're over here. So the second, the right-hand side starts at 3 and goes to infinity. Square, then round. All right, so to solve this quadratic inequality, same as the last one, find the zeros, think about the shape, up or down opening, decide whether you want to include with those square brackets or not, and write your answer, interval notation. And that's it for quadratic inequalities.